Welcome to Study Loop.
Hi. So in this problem, the diagram is the same. The figure is the same as the previous problem, but the statement is a bit different. So in the previous problem, DC was given, but DC is not given here. So the question the problem here is to find the value of DC. Okay. So what we are given here is that the maximum tension in the cable is 25 kilonewton, and we know that the maximum tension is in the steepest part of the cable, the part with the maximum slope. So this part here is DC because the maximum force is acting on here. So it will be stretched the most and it will be the steepest. So the tension here is 25 kilonewton. And we also know that this tension is it- nothing but the resultant of the horizontal and the vertical component of the reactions at E, because that is what brings the tension, the resultant of these two forces here. Okay, so this tension is nothing but this maximum tension, that is 25 kilonewton, is nothing but under root of ex square plus ey square. So remember this, we'll use this equation later also to, I'll tell you how. So the first to do this problem, we make the free body diagram of the entire cable. So what is and this is what is that? The only thing remaining here is the tensions at the point A, that are AX and AY. Okay, okay. And to solve this, we first take the moment about A, the point A. So we take the moments about point A and equate it to zero. Summation MA equal to zero. We know that a moment due to a particular force is r vector. There is position vector of that force corresponding to the point from at which we are calculating the moments cross, and the cross product of that position vector with the f vector, the force vector. This is the moment of one force in the complete system. And because the net torque, because the system is in a rotational equilibrium, the net torque about any point A or E would be equal to zero. So torque about A equal to zero, and the summation of the moments of all the forces about A, summation of r vector cross f vector, would be equal to zero. Okay, so we'll take one by one. We'll take the moments of all the forces about point A. So for this 2 kilonewton force, the force is acting downwards, so F is downwards, and R vector is like this, and R vector cross F vector is towards the whiteboard, and towards the whiteboard we are taking as negative, and to a negative torque, and towards us we are taking as positive torque. Okay, so so the moment of this force of 2 kilonewton would be 2 kilonewton, 2 kilonewton times the position vector, that is this here, is 5 meters. 5 into 2 is 10. So I'm skipping the writing the meter and kilonewton from now on. This will be 5 into 2, and for this force of 4 kilonewton the position vector is this, pointing here. The direction is same towards the board, so that is negative. This one is also negative, and negative 4 times 10, and for 6 kilonewton force is equal to minus 6 times 15, and for the force Ex there will be no moment, because it would be, because the angle, this angle between the R and Ex would be 180 degree, and we know that sine of 180 degree is equal to 0. The only tension would be because of this E phi. The only torque would be, or moment would be because of this E phi, and the position vector is 20. And its direction is, yes, it is 20, and in opposite direction to the torques of the two other forces, and it is plus Ey into 20, and this will equate to 0. So we take this minus 10 minus 40 minus 90 divided by 20, and negative of all this should be equal to Ey 140 divided by 2, 140 divided by 2 would be divided by 20, sorry, it would be, so Ey would be equal to 7 kilonewtons. I think that's similar to the last question. Yes, yes. And because we know this tension, this, like, I showed you here that this, because we know the tension equal to be 25 in the steepest part and the maximum tension, this is equal to under root of Ex square plus Ey square. Ey square we now know equal to 7 kilonewton. So 7 square, and this equation will give 5 square plus 7 square, 25 square minus 7 square, and yes, that's it. So 625 minus 14. So this should give Ex equal to 24 kilonewton. So using this Ex and Ey, we will now find DC. That was our main problem, to find this DC. And how would we do it? We will try to write an equation which consists of this DC. So one of the ways to do is to get the moments about point C. So one of the ways to do is to get summation MC equal to 0. Let me solve it here. Let me get the figure again. Okay. So we will take the moments about point C. So these lines are also gone. This AX and AY. So remember here that this is AX in the horizontal direction, this AY in the vertical direction, and this is E X. This is Ey. We know the values of Ex and Ey. Ex is 24 kilonewton and Ey is 7 kilonewton. And if we write the equation of for the moments at C, summation of m all the moments at C equal to 0, then let me write that equation first. So so the way we did it earlier, the equation would be something like this. Summation mc equal to 0, 6 into 5 the moment due to the 6 kilonewton force, plus Ex the moment due to Ex component, and because this is dc, the horizontal distance, and this Ex is in this direction, and the perpendicular distance or the r vector for this Ex equal to dc. So this should be Ex times dc minus Ey times 10. This is the moment due to the force Ey, and this is in the opposite direction to these moments, and this equal to 0. This equation is equal to 0. Okay, if we solve for, so we can also substitute the value of Ex and Ey here. So we substitute Ex and Ey. These values are known for Ex and Ey. We substitute these values. So the equation becomes 6 into 5 plus Ex was 7 kilonewton and dc minus Ey was sorry, Ey was 7 kilonewton and Ex was 24 kilonewton. I'm sorry. So this equates to 0, minus 70 plus 30. dc should be equal to 40 over 24. So this is equal to 1.667 meters. So dc we have got the answer as dc equal to 1.667 meters. We write it here neatly. dc equal to 1.667 meters. Okay, that's it. Thank you very much.